Now we will have the discussion on the Maxwell equation. On previous lecture that we have derived the Maxwell equation from the Ampere's law. Now we will derive the Maxwell equations from the Faraday's law. And Faraday, we know that the Faraday discovered that an electric current is induced by changing the magnetic field. Yeah, and Faraday, the law describes that the total induced EMF or the total electromagnetic force is equal to the change of magnetic flux with respect to time. Here the negative sign indicates the induced EMF is opposing the magnetic flux. And we know from the Gauss law this phi is equal to surface integral of B dot ds. Gauss law is nothing but the total flux leaving the entire surface can be obtained by the surface integration and substituting the phi equation to the induced EMF. Therefore, V is equal to minus d by dt into integration of B dot ds. And we know from the line integration of electric field, V is equal to closed path of E dot dl. Okay, therefore we are substituting the equation here. E dot dl is equal to, here you just see the differentiation term is outside the integration, and the differentiation is with respect to the time, the integration is with respect to the ds. Okay, so both have some different term, so I am keeping the differentiation term inside the integration term. Okay, there won't be any problem. Therefore minus integral of dou b by dou t dot ds. From Stokes theorem we know that the line integral of any vector field over the surface is equal to the surface integral of curl of that vector field over the surface. Okay, therefore E dot dl is equal to del cross E dot ds. And again I am substituting instead of E dot dl I am going to substitute del cross E dot ds. Therefore integration of del cross E dot ds equal to minus surface integral of dou b by dou t dot ds. Okay, and we know that the B is equal to mu h. B is nothing but the magnetic flux density, and H is nothing but the magnetic field intensity, and mu is nothing but the permeability. Okay, and cancelling the integration term and ds on both sides, finally we are obtaining that the del cross E is equal to minus mu dou H by dou t, and we can substitute mu for mu H we can substitute B. For del cross E is equal to minus dou b by dou t. And this is the Maxwell equation from the Faraday's law. And we can say that as the electromagnetic force around the closed path is equal to the magnetic displacement enclosed by that path. Thank you.